Expected value of a random variable. Suppose x is a discrete random variable for an experiment. So it's important here to know the difference between discrete and continuous. So discrete data, it must take a certain value. So for example, the number of people, number of tables. You can't have half a person, you can't have a quarter of a table. So it has to take a certain value. Shoe sizes are also discrete because although you can have a 5.5 or a 6.5, you can't have 5.25 for a shoe size or 5.99 for a shoe size. You can have 5, 5.5, 6, 6.5, 7, and so on. So shoe sizes, although they involve halves, they are actually discrete. Continuous is data that can take any value. So for example, height, weight, length, time, etc. So suppose x is a discrete random variable for an experiment, and x is equal to x1, x2, x3, and so on, up as far as xn. Let the probability of x1 be the probability that x is equal to x1, etc. So therefore the probability of x2 would be p is equal to x equal to x2, and so on. Then the expected value of x, written as EX, or the mean, is given by EX is equal to x1 multiplied by the probability of x1 plus x2 multiplied by the probability of x2 plus up as far as xn multiplied by the probability of xn. So this is equal to the sum of x times the probability of x. So this symbol here, sigma, represents sum of, so we add. Paul selects 2 cards at random and without replacement, this is important, from a pack of cards. What is the expected number of hearts that he gets? To choose 2 from 52 cards, the number of ways is 52 choose 2, which is 1,326. This is far too many elementary outcomes to be listed individually. So for example, if we started trying to list them, we could say we got king and ace, we got king and 2, king and 3, king and 4, king and 5, and so on. We would end up actually listing 1,326 possible outcomes. So we need to find an easier way to do it. Because the question is concerned with the number of hearts Paul gets, we should let the random variable x represent the number of hearts. We will need to calculate the probability of getting each possible value of x. This can be done by relative frequency or by the multiplication rule, which we will use here. So let the random variable x be the number of hearts obtained. Then x is equal to 0, 1, or 2. So if we're only choosing 2 cards from a pack of cards, then it is possible to choose 0 hearts, or 1 heart, or 2 hearts. I know that there is 4 hearts in a pack, but if we're only choosing 2, then it's only possible to choose at most 2 hearts. So these are our x variables. We can now construct the following extended probability table. So we have our calculations as the first column. We have our x values, so x is an element of x. We have our probability of x, and then we've multiplied our x values by our probabilities to get our final column. So starting off with 0 hearts. This would be our calculation. The probability of getting 0 hearts would be 39 over 52 multiplied by 38 over 51. So the 39 came from the fact that there's 39 non-heart cards over a total of 52 cards. And if we've taken one out and not replaced it, then there's 38 non-heart cards left and only 51 cards altogether left. 39 over 52 times 38 over 51 gives us 19 over 34. And 0 times 19 over 34 is 0. So this is our x value multiplied by our probability, and that gives us 0. Next, we're going to have a look at when our x value is 1, so the probability of choosing one heart. So we could end up choosing a heart and no heart, or no heart and a heart. So these are the way that we can choose one heart. So heart and no heart would be 13 over 52. There's 13 hearts over a total of 52. Multiplied by 39 over 51. There's 39 no hearts or non-hearts over a total of 51 cards left, because remember, one of the hearts was taken out. So and means multiply and or means add. So at this point we would usually add on the probability of no heart and heart, but it's actually the exact same as the probability of heart and no heart. So we can just multiply by 2. But if you want to write it out the long way, that's no problem. Multiplying these together, we get 13 over 34, and 1 times 13 over 34 is 13 over 34. Lastly, we're going to work out the probability of choosing two hearts. So this just means heart and heart. So there are 13 hearts in total out of a total of 52 cards in the pack. If we've chosen one, then there's only 12 hearts left over a total of 51, because again we took out one card. 13 over 52 times 12 over 51 is 1 over 17. And 2 times 1 over 17 is 2 over 17. Next we add them to get a total of a half. Thus the expected value is the sum of the x values times the probability of x, which is 0, plus 13 over 34, plus 2 over 17, which is equal to a half. So the expected number of hearts is a half. And this might seem a bit strange, because you might think, well, there's no such thing as half a heart or half a card. But if you were to think about if there was a survey done on the number of children in a family in the Dublin region, for example, it might end up to be 2.6 is the average number of children in families in Dublin. And there's no such thing as 0.6 child, a child of 0.6 value. But that actual average, that mean, could be realistic. So don't be distracted by fractions or decimals. It is alright to get a fraction or a decimal for an expected value, and it is actually probably quite likely. It is possible to have different random variables associated with a given experiment. For example, for the coin being tossed 3 times, we might consider the random variable y to stand for the number of identical outcomes. Then y would be equal to 2, 3. So if you toss 3 coins, there are only 2 different ways that you can get any identical outcomes. So you could get 2 heads or 2 tails, so that would be where the 2 comes from, or you could get 3 heads and 3 tails, so that would be where the 3 comes from.